Throughout this training demonstration, we've always used the default drainage.4d file. Now we're going to take a look at this file and see how we can customize it. Returning once again to our drainage menu, we're going down to More and going down to Edit drainage.4d. We're going to select Find so that it can find the drainage.4d file that's being used, and in this case it's one that's found in the local folder. We're going to the Folder button and down to Open. Now, taking a closer look at this file, first of all, any lines that have a double slash at the beginning are comment lines. Those are there for our reading only. 12D will ignore them. Moving down a little bit is descriptions about how the format is for the version 8 drainage.4d manholes. We're going to return to these after we look at an example. If we look down far enough, eventually we get to the end of the comment lines, those double slashes. So here's our first manhole definition. It's case sensitive and it must begin with the command manhole followed by a space. Inside a set of quotes is the name for the manhole. Each manhole name must be unique. Every manhole definition also will have an open bracket, and if we look down at the very end of this, it's finished with a closed bracket. There must always be an open and closed bracket, and it has to be the curly brackets. You cannot get creative and use the square or the round ones. The next line, manhole description. You notice that when we do pit schedules, we don't print them with AL2D in them, but rather we print them with this full description here. That's because a contractor building it will recognize this description, but may not recognize the small acronym that we use inside our drainage. The second is the notes. These become an attribute that you can reference. Other than that, they're not reported anywhere inside the 12D at this time. Inside our pit schedules, we also quote a length and a width of the inlet. That's where your length and width come from, the manhole size command. The manhole diameter that's used inside 12D is either going to be the default or, if you define it, the manhole diameter size here. So as soon as you select this manhole type, the diameter is changed to 0.93. This cap config value we've used several times throughout our training. I talked about how a pit can become an inlet, either sag or on grade, or it can be a manhole with a sealed cover and no inlet capacity at all. So G is the code for an on grade, S is the code for a sag, and M is the code for a manhole or sealed. We then get down, so this one is definitely an on grade. Then we get down to our cap curve grades. These curves determine the inlet capacity of our manholes. So this is the beginning of a cap capacity curve for an on-grade pit, and then it has a name. Once again, that name must be in double quotation marks, and it must be unique for this particular manhole. Now, this description that you have here usually is the description you'll find written on your inlet capacity charts. Once again, you must begin the curve with an open bracket and end in a closed bracket. Now 12D needs to know when to use this curve. So you'll notice here we've got the road grade and the road crossfall. So the tests for this were done at a 0.5% grade and a 2.5% crossfall, but we plan to start using this grade this curve at a 0% grade and a 0% crossfall. Then come the coordinate data. The first set of coordinates, the first number in the coordinates is your approach flow. The second number is the amount of water that goes into the inlet flow. So you can see for this example that we have 100% capture up to 60 liters per second. As soon as we get above that, it starts to drop off. By the time we get to 500 liters per second, we're only capturing about 50% of our flow. Then comes the next curve. This next curve the tests were done at a 1% grade, but we're going to start using it when the grade hits 0.75. Now you'll see that these grade ones, there's several grades, and they keep repeating to higher grades. We're up to 6, up to a 10% grade, 14%, and then we've got another one for another crossfall. So this one is, the tests were done at a 3.3% crossfall, but we're going to start using these curves when the crossfall hits 2.9%. And once again, that's repeated. Now there's a whole set of curves, and now we're down to another type, a 3-meter lintel, But I'd like to move all the way down until we find a sag curve. So going down a little bit farther, might do a search on this. There's our sag. Now this is the same type as above, but it's being used in a sag location. You'll notice that cap config is not G, but it's S for sag. Now the sag curves are a little bit different. First of all, there's only one sag curve per inlet. And the coordinates inside them are, first of all, the manhole depth, and the second value is the inlet capacity at that depth. So the depths are in meters, the inlet capacity in cubic meters per second. And you only have one curve for those. Now if we search for the manhole, MH, might have to search a little bit farther for that. Let's search for a uppercase MH and match the case. There's a manhole, a 1050. You'll notice that the cap config for this one is an M, and that we have no inlet capacity curves for this. You can never have an inlet capacity curve if your cap config is set to M. If you do not set your cap config, then inside the Drainage 12D editor, network editor, you'll have to select the type. So let's take a look at that. Let's go back to our network editor, and we're going to pick one of our inlets. And if we go to the pit and across to the main tab, what happens is if you don't have your cap config set, this drop down will be active and you can change whether it's an on-grade, sag, or manhole. Now, moving down to the very end, we have our pipe configurations. At present, they're very, very simple definitions. You've got the word pipe, once again case sensitive, the name inside quotes, an open bracket to stop, a closed bracket to finished. A very simple, straightforward definition. Now the order that these appear inside the drainage.4d file is the order that they will be used, the order that they will appear inside the lists, those drop-down lists. Now if we were to create a new pipe type, so if I was to take a copy of these lines and just paste it back in at the top, I could create a new type of pipe. So rather than a reinforced concrete pipe, now I couldn't put a PVC or one of the ones that are defined down before, but let's make up a class X, as if we're going to go with classes X, Y, and Z. Now if I save this file and go immediately back into 12D, I would not see it show up inside my network editor. Anytime you change an underlying file inside 12D's database, you have to do a project restart, or at least exit 12D and re-enter. Once again, if I go up to project, down to restart, that's the fastest way to do this. So if I do a project restart, it's going to come back up. And probably the fastest way to see if everything was okay is to go look at my defaults. So back to my defaults for my pipes. If I go to my drop down now, you'll see I have a new type X up at the top. Now when 12D starts up, it analyzes the drainage.4d file and checks to make sure if you've made any mistakes. So if we go to the window output window, and if I go up near the top here, you'll see it tells us all the files that it's found. And it's found the drainage.4d file in the current working directory. If there is any errors inside the drainage.4d file, you would see them listed immediately below here. It would tell you the line and the column that the error was found, or when it gave up. Usually the error will be just before the line or the column quoted. We are now going to return to the drainage.4d file to discuss some of the more advanced aspects of inlet capacity. Let's move down a little bit more and talk about the inlet capacity curves. So far we've talked about curve coordinates, the idea of having the Q approach versus the Q in. Now you also have the capability of doing a regression analysis along your curves and modeling them as either a fixed inlet capacity, a percent inlet capacity, or an exponential one. So let's zoom down a little bit farther to see the equations that are used for that. First of all, inside the cap curve, the inlet capacity is the fixed capacity that you specify, plus the percentage plus the exponential, and of course plus the curve. So the idea is that 12D adds up everything that you've specified. Now, everything that's calculated from the curves can then be multiplied by a multiplier, cap multi. Now, all of these values can be defined inside the cap curve so that they can change once again with road grade and road crossfall. Now, if you define these exact same values but do not put them inside the curve, but put them outside the body of the curve, so let's go down and take a look at an example. If we were to go down here, for example, and outside all of the curves, put in a cap multiplier, cap multi. Now this is not inside a curve but outside a curve of 2, then all of the values calculated would all be multiplied by 2. So everything that you've done inside a curve definition, except for coordinates, can be done outside as well. So that's part of that inlet capacity details. Now, the other thing that we can do is that all of these values get multiplied by choke values inside the drainage.4D. So let's go back once again and grab the network editor, select one of those inlets, and go back to our defaults for our pits. You'll notice down below here that we have choke factors for the on-grade and the sag pits that change for the minor and major events. Now, choke is always a somewhat difficult term to use. I like the idea of an inlet efficiency rather to be used instead. So a value of 1 means it's not restricted at all. A value of 0.8 means that 80% of the calculated value goes in. Or if you're at a sag, 50%. So the idea here is also think of it rather than a choke, try to think of it as an inlet efficiency.